Hello viewers, welcome back. Today we'll discuss about cyclic interruption block called OB30 or 30 plus. As we know that OB main cyclic interruption block OB1 execute cyclically or called periodically without any interruption. Once the execution is finished, it will start the execution again without no delay, and you can call all of your user program in OB1. But cyclic interruption block used for a special purpose where you required to your program execution in interruption. So in main OB block you can call all of your user program here. From it will execute from here to here all of your user program, then after finish it will execute again from start. But for cyclic interruption block it will execute your user program, then wait or interrupt for your specific time, then start it again. One thing you have to know that during the execution of cyclic interruption block, your OB execution will be pushed. After execution of your interruption block, it will resume the execution of OB1 from the breakpoint of OB30 cyclic interruption block. Now, how we can use this cyclic interruption block? We can give a example. Let's see a train. Here is a train of a flow meter. This is a flow meter of a belt scale. That flow is a 400 TPS, and the range of this belt scale is 600. But belt scale flow is not constant. If it is constant, then we can easily calculate the how many material is passed through this scale. If it is constantly 400, then we can say 400 TPS means 400 ton per hour. Then we can call that the material passed through this scale 400 ton. But this flow is not constant. It is fluctuating. It is changing with time. So how can we calculate this material flow, total material flow with this scale? To do this, we have to sample in each changing point. If we can find this changing point value and time, then we can easily calculate. Okay, let's see how we can calculate the total material flow through this scale. I have created a totalizer block here. That totalizer block I am calling in cyclic interruption function. Yeah. Okay. Here is the material flow. Let's say it is 30 TPS and period is 60 minutes or 1 hour you can give. And cycle, if we use this function without, if we want to calculate the flow without cyclic interruption block, then we can use the uh, clock memory, because we have the clock memory which has a 100 millisecond pulse, and is 100 millisecond pulse we have from, so we can um, sample this trend in 100 millisecond is, and this is 1.0 is clock is 10 hertz, means in is 100 millisecond it will give a pulse. So, and I want to use a p tick here, because it will up in is 100 millisecond it will high for 100 millisecond within this 100 millisecond, and it will be give a wrong value, because our main, if we call this function in OB1, OB1 will execute in each second or near about this. So in 100 millisecond it will add 100 times. So I am using a PT, for each time it will high it will give a one pulse, it will calculate for one time. M30.0 I am using a plug memory. Okay, and cycle time here is 10 hertz, means 100 millisecond. I have to give a 100 millisecond here. Now we have to call this block in OB1. I am using this function calculating this material flow without cyclic interruption first, then we'll use the cyclic interruption block. Let's download it. So material flow is now this mass. I am using here 30.1 memory plug for reset. So now current value is 981. I am resetting this value to 0. Now 0, it will start calculating. So in an hour this value should be 30, and we cannot wait for 1 hour. So think this is a 30 turn per minute, give a 1 minute. So unit is a 30 turn per minute. Now I am resetting this value again 0. So this value, total value should be 30 in 1 minute. Can wait 30. So it is almost 15 in 30 seconds. Okay, we can use this totalizer in cyclic interruption block 2 without using this clock memory, because clock memory not less than 100 millisecond. We the system clock memory only we can take less only 100 millisecond, not less than this. So if we take a sample less than the 100 millisecond, then your totalizer value will be more accurate. Okay, so to do that we can use the cyclic interruption block, because we can give the cyclic interruption block 1 millisecond to 6 millisecond 6 second you can give. So that time you don't need to use this clock memory. You don't need to use this. Suppose I want to use the 50 millisecond cyclic interruption block. So and there is no pulse here, because it will execute. When it execute, it will calculate, and and it will wait for 50 millisecond. It will not execute for all time. Now I am creating the cyclic interruption block called OB30. If you have more than one cyclic interruption block, then it will be 30, 30, 29 or 31 like this. So here by default it is 100 millisecond, because it is in microsecond. So I want to use 50 millisecond. So this is 50 millisecond cyclic interruption block. You can go in properties, here 50 millisecond, and this phase shift, if you have more than one cyclic interruption block, that time you should use this phase shift, and phase shift will define that your both cyclic interruption block should not start at a time. So if you give a offset here, it will overlook for this microsecond. Okay, I am calling this cyclic interruption block FC here and deleting from the main OB block. So I am not execute this cyclic interruption block in OB1. I am using this one. So you can call your cyclic interruption. You can call your user program in cyclic interruption block also in OB1. Now I am downloading it again. Let's see it is adding or not. I'm going online. Yes, it is adding. It is adding. So without this, it is adding. So if I reset it, it is 0. So after 1 minute, the value should be 30. So this is the use of cyclic interruption block. Okay, thank you guys.